Hello, y'all. This is Darrell Lee Berry Jr. going over some linear algebra. I'll be going over various topics in the chapters that'll be covered in the exam I'll be doing tomorrow. This first one will be curve fitting. And basically, I'll just go through various problems. I'll do this problem. I'll make another video on another problem or concept, and I'll continue to cycle through them. So this particular application is in chapter 1.6, curve fitting. So the idea is that we want to find the equation of a line passing through 2 points or 3 points. So we have a Cartesian space, and we have the point 3 points, 1, 1, 2, 5, and -2, -11. So these are the data points we have. So let's say they're here, here, and here. Now you want to find some line of best fit connecting these points, between these points. So the book says you could just do the point slope form on each point. Let's go ahead and do the matrix way. You want to find y equals mx plus b during doing linear algebra for each of these points. So if I look at this, this is x, this is y. So 1 equals m1 plus b. 5 equals m2 plus b. And -11 equals m-2 plus b. So all I did was input the x's, where the x's go, and put the y's, where the y's go, and the y equals mx plus b format, which gives us a system of 3 equations. So we can solve this with Gaussian elimination and say 1, 5, -11. Actually, let me put it the proper way. It'll be 1, 1, 2, 1, -2, 1. And this is going to be MB equals 1, 5, -11. So if I also make a augmented matrix, this augmented matrix would be 1, 2, -2, 1, 1, 1. And that would be 1, 5, -11. And from here, I'll do row reduction and say row 2 minus 2 row 1, row 2, row 3 plus 2 row 1, row 3. So this is going to be minus 2 row 1, minus 2, minus 2, minus 2, plus 2 row 1, plus 2, plus 2, plus 2. So now I have 1, 1, 1, 0, -1, 3, 0, 3, negative 9. And I can reduce this farther. I can say row 3 plus 3, row 2 to row 3. So that's going to be 1, 1, 1, 0, negative 1, 3, 0, 0, 0. And we expect to have a free variable since we're only looking for two variables. And if I was to multiply this by negative 1, now I'll just do that here. And actually, let me add this first. So row 1 plus row 2 to row 1. So we have 1, 0, 4. And now I'll add the negative. 1, negative 3, 0, 0, 0. And I was multiplied to negative 1. So I added row 1 to row 2. This made this one a 0, made this one a 4. Then after that, I multiplied by negative 1 on this row after I added them. So that became 1, negative 3. So now we have that m equals 4 and b equals negative 3. So y equals 4x minus 3. So this will be the line of best fit from the data points. So that is awesome. And let me check the answer. Yes, it looks like that's correct. Easy enough. So that's how we can solve a system of equations with row operations, linear algebra, to get a line of best fit from a series of data points. So I may be able to use this in my lab I'm doing now. I'll take a look and see how that works. So if I have a bunch of counts per counts per energy. So energy I have count. So it'll be energy count. And I should be able to make a system of equations to find it'll just be very complicated unless I make some kind of program that can do it, but should be easy enough to work out. But if not, I do it a different way. So awesome. I'll be back momentarily. I'll go over the next concept I'll be doing, which will be 5 ways of doing matrix multiplication. So, for a moment, I'll be back on 5 ways of making matrix multiplication. We'll go from there.